Hey, will you flip the left light switch down? All right. Eduardo, you have still have this quiz to finish up, okay? And Grant, you have quiz 11, A through E to do. Cooper, you have G through M to work on. And you have G through M, the other one. And Grant, you have 9, F through K. Cool.
What's the blue one? What numbers is that?
11, A through E. All right, 10. 10 D, right? 10 D, right?
Yeah.
I don't know.
Well, no problem. Then go to the review. All right.
I do.
I still don't understand race.
I think it's okay.
Do what?
I still don't understand race.
It's like
The sum yet?
It's talking about 5 grades and what they do.
All right. What were the sum equations? There was the arithmetic. What was that equation? What did this look like?
It makes sense.
What was this for arithmetic? It was in yesterday's notes. Anybody got yesterday's notes? I don't. Let's see. Okay. Yeah, and it usually starts with 1. I just put boxes because you really can start anywhere on it. What was the arithmetic? Huh? Yeah, usually they start with 1. It could really start with any number though. Look at yesterday's notes. And we had geometric. And then we had the other geometric. We had the geometric infinite. The geometric that was finite. What was the arithmetic sum one? Wasn't it n? And then this was a1 plus an over 2. Is that it? Did I remember at the top of my head? Okay, cool. And geometric, and then we can have it, whatever numbers in here we want.
So is the top one D?
This D? What do you mean D?
Like the common difference?
This top one is actually the nth term. And then this one is usually 1. But if this was like a sub 3, then we have a 3 here. And then what was the geometric? It was... What was that one? Is it... I know that we had like 1 plus r to the n over 1 plus r. But I forgot what was out front. Is it a sub 1?
Yeah. A sub 1, yep.
Okay. And so this is for finite. So usually this would be a 1 and this would be some other number or hashtag in your guys' lingo.
Hashtag.
And then the infinite one was this. N equals usually 1 to infinity is on the top. And then we had A1. And then what was it?
Over.
Oh, it's over? Okay. Could be. A1 over 1 over R or something like that? 1 minus R? Were those both plus there?
Those are minuses.
Those are minuses, okay.
Yeah.
Minus there and minus there, okay. And so, and if this is ever arithmetic and it's infinite, then that means it would go to either positive infinity or negative infinity, right? All right, what did we have? What questions did you come across on the homework? 19 and 27? Okay. Oops. Helps when I'm in the right section. says summation of n equals 1 to 150, and then n. Yeah. Thanks, buddy.
Yeah, thanks, man. I'll be back tomorrow to do one.
So that means I'm gonna plug 1, 2, 3, 4, 5, 6, 7 all the way up to 150 in, right? She is in a test right now. So what I could do is this. This is 1 plus 2 plus 149, 150, right? Less than you. So what I can do is I can go 150 plus 1. That gives me 151. And then how many pairs exist between what's half of 150? So whatever 75 times 151 would be. Cool. What was the other one you said? 27? Does everyone understand why I got 75? Because there's 75 pairs from, and then 27. We got okay. So infinite geometric. So that means it's going to be S at n is equal to a sub 1 over 1 minus r. So if I plug 1 in here, a sub 1 would be 1. So that's going to give me 1 over 1 minus my ratio, which is 0.4. So that's 1 over 0.6. Sometimes that's hard to decipher what that actually means. So that's 1 over 6 over 10 multiplied by the reciprocal. So that's going to become 10 over 6, which is 5 over 3. It's a fraction what to sum up to. What else did we see? We good? Yo. 11. Says summation of and I would say that's not arithmetic nor geometric. Oh, it could be arithmetic. We could do it this way. So 1 squared minus 3, 2 squared minus 3, 3 squared minus 3, 6, 4 squared minus 3 is 13. So that's going to be -1 plus 19, 18. And the reason I just didn't plug into the arithmetic was there was only a handful of them. Anything else?
Can you do 3?
15 and then 3? Let's do 3 first. So we want to do this. So we want to sum the first 16 terms. Okay, so I'm looking at this and it looks like my common difference is -2. My first term is 33. Let's figure out my equation. So a sub n is equal to a sub 1 plus n minus 1 times d is the general equation. So let's figure that out. So it's going to be 33 plus n minus 1 times d, which d is -2. We can clean it up a little bit. So I'm going to get 35 minus 2n is my nth term. Is that okay so far? Let's see. So I guess all we really need to do is find d on that, because what was my general equation on that? It was that, wasn't it? So it's going to be Oops, I'm on the wrong problem. So I'm going to do summation of n equals 1 to 16 of my first term. What was the rest of it? Or n, okay. That should have been an n right there. N first term, last term, divided by 2. So I have 16 terms. My first term is 33. My last term I'm going to find by plugging 16 into this. So 2 times 16 is 32. 35 minus 32 is 3. I could reduce here if I wanted to. So I get whatever 8 times 36 would be.
Wait, why is it 1 and not? Cause, oh, never mind.
You good? And what was the last one someone asked for? 15.
Yeah.
15. So, is there a variable for me to plug anything into? No, so my answer is just 3.
Are you serious?
It's a constant, yeah. Good? Alright. So why don't we just say we'll put a 4 out of 4 in there for everybody. Don't worry about turning that in. If you have anything old to turn in though, come put it in the orange folder. And I'm going to the very last pages of the workbook. Not including the answers. So it looks like it starts on page 201.
Yeah, and it goes
So anywhere you want me to start on that?
17 pages.
No, just start. Like,
I would start from the beginning
just
and
start from
then
the
go.
beginning.
Yeah.
All right.
The statistics.
Statistics. All right. So, so it says Cherry Creek students are taking the Explorer test for their freshman year and then take the ACT their junior year. Below are the composite scores on both tests for 25 randomly chosen students from the class of 2013. So it looks like the Explorers, you have a score of 22 and 33, 14 and 18, below and so on and so far. And then what does the slope mean in the context of this problem? So our slope of our linear equation is 1.35. Agree? So my y value on that, my Explorer would be x, my y would be ACT. So I'm going to do, I would earn 1.35 more points for every 1 point on the ACT that if I earn, okay. So I earn 1.35 more points on the ACT for each point I earn on the Explorer. What does the y-intercept mean? A student that didn't take the Explorer is expected to get a 1.12 for an ACT score. And if someone got a 23 on the Explorer, which is the X, predict their ACT. So this is number 3. So this was the given equation. And so they wanted us an Explorer score of 23. What would they expect to get on the ACT? Well, the ACT is Y. So you'd go 1.35 times 23 plus 1.12, and that would be their ACT score. And how far off was their estimate for a person who got a 14 on the Explorer? So 14, 1.35 x. This is based on our equation. So subtract 1.12. That's going to be 12.88. equals 1.35x. Does anyone have a calculator? If so, it would be really helpful. What's 12.88 divided by 1.35? How much? 9.5. Okay, so we're saying if you got a 9.5 on the Explorer, then you would get a 14 on the ACT. Then let's look at our data. Did anyone earn a, well, let's round it. No one earned a 9.5. Does anyone earn a 10 on the Explorer? No. I don't know if we can answer this question. Let's see. Did anyone earn a 14 on the ACT? No one earned a 14.
No, it's like if you get a 14 on the Explorer and you plug that in, and how much is that, like, in terms of the equation? Like,
Did I read it wrong? How far off was the estimate for a person who gets a 14 on the Explorer?
so if you get a 14 on the Explorer and you plug it in X.
I should have plugged a 14 in here.
Yeah.
So what's 1.35 times 14 plus 1.12? Because
Like 20.02.
20.02? That's incorrect information. 20.02 on the ACT. All right, so did someone get a 14 on the Explorer? Yeah, looks like the data showed a 14 on the Explorer. They got an 18, whereas our equation showed pointing to that if you got a 14, you should have got a 20.2. So how far off are they? 6.2 off, points off, or 2.02 off? Yeah. 2.2. Is that right? Cool. That's about it. All right, and then it says ACT scores are designed to be a normal with a mean of 21.1 and a standard deviation of 5.1 using the Z table or calculator. Okay. So 5 through 9. So I'm just going to draw the normal distribution curve. So they're saying 21.1, and then you have a standard deviation, so that's the mean. And it says a standard deviation of 5.1. So one standard deviation to the right, you'd add 5.1, 26.2. Two standard deviations would be a 31.3. If I went this way, I'd subtract. So that's a 16. I subtracted 5.1 again. So I'd get to 10.9. Okay. And so that's what our normal distribution should look like. So 68% of our population should fall in here. 95% of our population falls in between these two.
Why? Is that just like how standard deviation?
Yeah, that's how a normal curve would work. And then if I went out one more standard deviation this way and one more this way, we would, between these, we would have 99.7% of our data would fall between that. So you only have 0.3, which are extreme outliers. Okay, so the Z-score was a certain equation. Anyone recall what that was? I don't recall off the top of my head. So, guess what we'll do? The goo-goo. Oh, I got a marker right here. Wait for Z-score. I just want regular. That one. There we go. Z equals. I wonder if this is going to work. Copy. Paste. Hey, it worked. Cool. All right. Of course, you guys can't see that, so let me write it bigger. So the z-score is x minus our mean over our standard deviation is what it is. So let's find out what our z-score would be. What percent of the students score below 21.1? So I'm going to do this, 21.1. Oh, we already know that the answer to the first one is this. How many people fall to the left? If I had a z-score of 21.1, my standard deviation, I have half to the left and half to the right of the average. So 50% of my students scored lower than a 21.1. And then what
How much
percent?
statistics is on the final?
It's the whole thing.
It's just one stat problem.
So I would say 1 or 2 problems.
You have to memorize the z-score.
I'd give
Like
you the
this?
z-score.
Like
problems
this,
are
as
total
in it's
answers.
like one thing and then there's like questions,
No, it might just say,
like 2 questions.
find the z-score, and I'd give you the z-score equation.
Is the big part of
Yeah, is our final 20%?
What
So you know how last semester we had like a big part of our final that was just like what kind of graph is this? Like what thing is happening here? Is that like gonna happen in this final too? It's just like graphs and stuff.
I mean, you will have graphs, but I imagine where your review is going to be focused on.
No.
All right, what percent of students scored below a 25? Okay, so do I have a 25 as one of my markers?
No.
No, so then I have to find the z-score of that. So I'm going to say z equals 25 minus my average, 21.1, over my standard deviation, which is 5.1. Okay,
How'd you get 5.1?
standard deviation I was given.
Oh, okay.
Someone with the calculator, 25 minus 21.1. 3.9.
Yeah.
Divided by 5.1.
0.76.
0.76.
Yeah, 0.7647.
So figure this. This is about where a 25 would be as far as a score. So you're talking about how much area would be over here, and it would be 76.5% of the people would score below the score of a 25. That means that 23.5 would score higher than that on a normal distribution. Okay, and then what we have a student who scored a 35 on the ACT. Is that unusual? Okay, so think about where 35 is. The 35 is down here. So you could find the z-score of it saying, well, if I had a 35 minus a 21.1 over a 5.1, 35 minus 21.1 is 13.9, I believe. 13.9 divided by 5.1.
Which one are we
The person who scores 35, we want to know if it's an unusual.
on? Oh, so it is unusual.
It's very unusual. It's like well over 90% of the population would score below that. I mean, could be like, gosh, if I found my next standard deviation, which is this one, 5.1 added to that is going to be 36.4. So 0.3 would score outside that. Actually, it's 0.15 because you have 0.15 of the area this way. So you have a really
Came out to 2.7.
2.7. So 2.7 means you're 2.7 standard deviations above the mean. So this is 2.7. So you're talking about an extraordinary amount of people that are going to score below that. So it's kind of unlikely somebody would score that high.
I'm sure
Yeah.
kids have done it.
Oh no, we do definitely have students that do, but you have not your entire the whole population as a whole would score below that.
Yeah, we're not all that kids flying to DC to take that pre-calc or whatever.
I mean, we had, what was it, last year on the ACT, we had 23 perfect scores in the district and 15 or 16 of them from Creek.
It's crazy.
Yeah. Some's in the water over here. I don't know. All right, let's see. What percent of the students score above a 30? So think about where a 30 would be on this right here. Here would be a 30, somewhere in that region. So we're talking about what percent is going to fall over here.
30 is a pretty good score.
36 is the top score, yeah.
So if you got like a 30, that's like a pretty good score.
The average is like 21.
Mhm.
No, it's like.
I don't know what the
The
average is.
I thought the average was like
Like
24.
Oh, it's like really low. Hannah got like a 32 or a 34.
Well, figure this. You are comparing yourselves to every kid that would have taken this test that particular year. So they renorm it every year. So the average goes up and down a little bit. And standard deviation changes a little bit. So there's certain years you might have had a better mark than other years if you were taken with if you took with a really dumb population as a whole, as a nation, and you did really well, you could have a higher score.
My sister got like a 36 on hers, and I'm just like, how?
Dude, that's awesome.
I'm just up in here trying to do high school, and she's just like straight up being genius.
So are you freshman?
Cool.
Now I'm a
Sophomore.
sophomore.
Double up. All right, flip the page. See where we're at. I'd say we wouldn't go too far into detail on those.
Okay.
Can we just skip those?
Let's see. Number 10 says the number of coins in a wishing well has an average of 140, standard deviation of 20. And using our rules, what are the probability of? Okay. All right, we can draw a normal curve.
Anyone seen that video of that guy stepping into like a wishing well and just scooping up all the coins? Standard deviation is 20. So you got 160, 180. I guess if you wanted to go 200. This way, do the same thing, subtract 20, so I get 120, 100, and 80. Alright, so the number of coins in the wishing well has a mean of this. Standard deviation that use our 68, 95, 99, 7 rule. So, between one standard deviation, so from 120 to 160, you're talking about 68% of your population. From 100 to 180, talking about 95% of your population. And then from 80 to 200, talking about 99.7% of your population. So I think based off this, we can figure out everything. Probability that there's 120 or fewer coins. So I have here. So I'm talking about the region that's going this way. So think about this. Let's say 100% is everything. And I know it's 99.7, but if we keep going and going further, we approach 100%. Okay, so we want less than 120. So I know I'm definitely going to subtract the 68% from that. And so that gives me 32%, which is here and here. So I want to divide that in half because I only want one of it. So that means 16% of my population falls over here. Okay, so I have a 16% chance that there's less than 120 coins in this wishing well. I'm thinking
This wishing well sets out a certain amount of time, then someone collects all the coins, then people start throwing money back into it. Does that make sense how I broke up the areas? And then more than 120 coins? Well, more than 120 coins is this way. So 16% was that way. So if I go 100 minus 16, I'm going to get 84%. I would have more than 120 coins in there. And then between 120 and 160. So what's between these? How much?
68.
68. So I got 68% that falls there. That's C. Fewer than 140 coins. So this is my average. So if I'm going fewer than that, there's 50% of my coins. And less than 80 coins. Oh. Okay, so this little region out here and this little region out here encompass 99.7 is everything. So if I go 100 minus 99.7, I get to 0.3 are my two extreme tails. If I divide 0.3 by 2, so that's 3 over 20. So, excuse me. What's 3 divided by 20? Excuse me.
0.15.
0.15. So we have a 0.15 chance that we have less than 80 coins in there. And then between 100 and 180 coins. Between 100 and 180. So that's out to there. So you're talking about 95% of your population. Between those two. 95%. Be better if I choose a different. 95%. 95%. Cool. Hey, we're done with stats. Yay. Okay, I'd say got less than 10 minutes left. Take a look at 8 and 9, 8 in the trig unit. And we'll focus on those tomorrow. Cool? Sound like a deal, Neil?
Yeah.
Who's Neil? No, that's a guy named Neil.
Neil Patrick Harris.
Doogie Howser, man. So.
Isn't he an alien? The movie with the